Hello, everybody. Welcome to the Priyanka Neela Krishnan show with me, Priyanka Neela Krishnan. And this is Enterprise Security Series, episode 39. And today's topic, the door was already open. And if you care about where breaches actually begin, this is the show for you. As always, one quick thing upfront. This is an independent commentary, my own views, not those of any employer, and nothing here is tied to any product or vendor. Today, we are talking about the unpatched door, the unknown vulnerability that sits open long enough for someone to walk through it. This is not a story about brilliant attackers defeating your defenses. It is a story about volume, about backlogs no team can clear, and about a race between two clocks that is quietly rigged against you. If you have ever felt like your patching program is running as fast as it can and still losing, this episode explains why and, more importantly, what to optimize instead. Give me the next 15 minutes and I'll show you the metric that actually decides whether an open door becomes a disaster. Most breaches are not clever. The attacker did not invent a new exploit in your honor. They walked through a door that was publicly documented, sometimes for months because the patch never got applied. This episode is about the widening gap between how fast vulnerabilities are exploited and how slowly they get fixed, and why the answer is not simply patch faster. I am Priyanka Neela Krishnan, and today we're going to talk about the open door. Something important shifted this year and it deserves your attention. For as long as most of us have been in security, stolen credentials were the number one way attackers got in. Phishing, credential stuffing, info stealers. That was the story. This year, the story changed. In the 2026 Verizon DBIR, exploitation of vulnerabilities became the leading initial access vector, overtaking credential abuse. I repeat, in the Verizon breach report, exploitation of vulnerabilities became the leading initial access vector that's overtaken the credential abuse. The most common way attackers break in is now a software flaw that was already known, already documented, and often already had a patch available. This is not a 0-day story. This is a story about doors that were marked open on a public list and stayed open long enough for someone to walk through. And the reason they stay open is not laziness. Definitely not. It is that the volume has outrun the capacity to close them. Let me be precise about what a known vulnerability is. Because the phrase does a lot of quiet work, it means the flaw is public. The flaw is public. It is on a list. Often there is basically a patch available under vendor adversary telling everyone, including the attacker, exactly where the weakness is and how to reach it. So when a breach starts this way, it is not that your team was outsmarted. It is that a published weakness stayed open long enough for someone to use it. And the reason it stayed open is almost never negligence. It is the volume, the huge volume. There are more disclosed vulnerabilities than any team can test and patch. So a backlog is guaranteed. The question is not whether you have open doors, You do. It is which ones lead somewhere that matters. You do have open doors. So the question is, which ones lead somewhere that matters? The core problem, two clocks running at completely different speeds. The, one second. Let me close this. Oops. Yeah. The attacker's clock is fast. A vulnerability gets disclosed, it gets weaponized, and it gets scanned for across the entire internet within hours to days. Verizon has documented edge devices and VPN appliances being hit within days of a disclosure. The defender's clock, that is, the good guys, the defender's clock is slow, and for good reasons. You have to test the patch so you do not break production. You have to wait for a change window. You have to weigh the business risk of downtime before you make the patch available in the production. That is responsible engineering. And it is also why remediation stretches into weeks or never happens at all. I've seen that multiple times in real life where there is a patch, there is a vulnerability disclosed, there is a patch that the team is working on, patch is available. Now you need to have that specific version upgraded, patch to be deployed. There are like various things depending upon where that is running, basically where that code is running. Is it in a very important stock exchange kind of a place where the code is running? Where is the code running? And you need to really think about the downtime before the patch gets deployed. That's responsible engineering. The gap between these two clocks is the vulnerability more than the flaw itself. As long as attackers move in hours and defenders move in weeks, the calendar will always favor the attacker. Here is the detail that makes the two clocks so unforgiving. ReliaQuest found that 71% of critical vulnerability alerts track back to a handful of well-known, years-old flaws that keep getting redeployed at cloud scale. So this is not primarily a race against exotic new 0 days. It is a failure to close doors that have been documented for years, reintroduced every time infrastructure gets rebuilt from a template that still carries the old weakness. The attacker's clock is fast because they only need to scan for a known signature. Your clock is slow because closing it means touching production. And every rebuild that copies the old flaw resets the whole race in the attacker's favor. Here is the headline number. 31% of breaches now begin with the exploitation of a vulnerability. That is the single largest initial access vector in the 2026 DBIR, and it is well ahead of credential abuse, which dropped to 13%. So we have a clear changing of the guard. The way in used to be the person, and now the way in is the unpatched machine. And I want to be precise about what this means for how you spend your attention. If a third of breaches start with a known flaw, then your vulnerability management program is not a back office hygiene task. It is a frontline control, arguably your most important one for initial access. The organizations getting breached this way are not being outsmarted. They are being outpaced. Let me connect 31% to where you spend your attention. For years, most programs put effort into the human vector. Phishing training, credential hygiene, and that work still matters. But The data just told you the largest single way in is now the unpatched machine, not the tricked person. That should shift how you weigh your program. If a third of breaches start with a known flaw, your vulnerability and exposure management is not back office hygiene. It is a frontline control, and the organizations getting breached this way are not the careless ones. They are the ones whose remediation capacity simply could not keep pace with disclosure, which is nearly everyone. And notice the contrast hiding inside this number. Exploited vulnerabilities at 31%, credential abuse down around 13. For years, those were reversed in our mental model, and many programs are still funded as if the tricked person is the main way in. The data says otherwise now, and the window is brutal. For the flaws attackers care about, the exploitation often begins within hours of a proof of concept going public. Sometimes faster than a change approval board can even convene. That is why raw severity scores are the wrong sorting key. What you want to know is not how bad a flaw could be in theory, but whether it is being used right now. Fund the program that answers that question, because that is where a third of your breaches are starting. Now, here's why patching faster on its own is not going to save you. Two numbers. First, only 26% of known exploited vulnerabilities were actually remediated last year, and that is down from 38% the year before. So, not only are we fixing a minority of the flaws that attackers are actively using, we are fixing a smaller minority than we used to. We are losing ground. And second, when organizations do remediate a critical vulnerability, the median time to do it is 43 days. Attackers exploit within hours to days. 43 days versus a few days is not a race you win by running a little faster. It is a structural mismatch. The lesson is not try harder at patching. It is that patching cannot be your only line of defense, because the math guarantees a permanent backlog of open doors. Sit with the direction of that first number for a second. We fixed a smaller share of actively exploited flaws this year than last year. That is not a plateau. It is a slide backwards, and it happened while the volume of disclosures kept climbing. So the honest conclusion is that the backlog is permanent and growing. Anyone who tells you the answer is just patch faster is selling you a treadmill. 43 days of median remediation against an exploitation window measured in hours is not a gap you close by sprinting. It is a gap you survive by making sure the door that stays open does not lead to your crown jewels. That is a design choice, and it is the one you can actually make. So, here is a reframe, and it is the through line of this whole series. You'll never patch everything in time. Accept it. The math does not allow it. So the goal changes. If you cannot keep every door closed, make sure the open door leads to an empty room. What determines whether an exploited vulnerability is a minor incident or a career-defining catastrophe is not the flaw. It is what the compromised system can reach once the attacker is inside. This is why data governance and least privilege are the real answer to a problem that looks like a patching problem. If the exploited server can only touch the data it truly needs, the breach stays small. If we can pivot to everything, you're writing an 8K filing. The vulnerability decides if they get in. Your access design decides how much it costs you. Let me make empty room concrete because it is the most important idea in this episode. When a server gets compromised through an unpatched flaw, what happens next is entirely determined by what that server can reach. If it was scoped to only the data and systems it truly needed, the attacker is stuck in a small box and you have an incident. If it could reach everything because access was broad by default, the attacker pivots to your whole environment and you have a disaster, not an incident. Same flaw, wildly different outcomes. And the difference is not the patch. It is the access architecture you built long before the breach itself. This is why the vulnerability problem is really a governance problem in disguise. 3 moves. First, patch by exploitation, not by severity score. Prioritize the vulnerabilities attackers are actually using in the wild right now over the ones that merely score high in theory. A flaw being exploited this week matters more than a 90.8 from last year. The 9.8 from last year that nobody is touching because we usually score it in up until 10. Second, shrink the blast radius. Segment your environment and scope access so that a compromised system cannot reach sensitive data it never needed. You cannot close every door. That's clear by now. So contain the rooms. And number 3, instrument for detection. Assume something will be exploited some point and make sure you would actually see the lateral movement and the unusual data access quickly in hours and not in the 43 days it takes to patch. Detection is what turns an open door into a caught intruder instead of a silent tenant. On patching by exploitation, let me give you the practical filter. Public catalogs of known exploited vulnerabilities exist for exactly this reason. Start there. Not with raw severity scores, because a flaw attackers are actively using this week is a real threat, while a high-scoring flaw nobody is touching is a theoretical one. And on detection, set your expectation correctly. You're not trying to catch the initial exploit, which will sometimes get through. You're trying to catch what happens after the lateral movement and the unusual data access in hours instead of the 241 days that breaches average. Fast detection converts an open door into a caught intruder rather than a silent long-term tenant. So, the takeaway for this one, the flaw decides whether they get in. Your access design decides what it costs you. Stop measuring your program only by patch speed, because that is a race the calendar rigged against you. Measure it by blast radius, by how contained a breach stays when, not if, a door gets left open. That is a fight you can actually win. We want to have winning fights, aren't we? In the next episode, we turn to a data leak that does not need a vulnerability at all. Because your own people are opening the door and walking the data out. It has a friendlier name than it deserves. We call it Shadow AI. I am Priyanka Neela Krishnan. Thanks for watching. So the reframe to carry out on this one is a shift in what you measure. Patch speed is a real metric. Keep it, but it will always disappoint you because the math is rigged. Blast radius is the metric that tells you whether your program actually works because it answers the only question that matters on a bad day. When a door gets left open, how far can they get? Optimize for a small answer. That is a fight the calendar cannot rig against you. This is the source slide. And this is episode 39. Here is the takeaway. Patch speed is a real metric, but it will always disappoint you because the math is rigged against it. Blast radius is the metric that decides your bad days because it answers the only question that matters when a door is left open, which is how far can they get? Optimize for that answer. If this was useful, please do subscribe so you do not miss the rest of the arc and share it with someone who is drowning in a patch backlog because they need to hear that the answer is not just faster. Tell me in the comments which you measured today, patch speed or blast radius. Be honest. I am Priyanka Neela Krishnan. This has been my independent commentary on enterprise data security. And I'll see you in the next one. Until then, stay safe, stay secure, be happy. Bye everybody.